Well, here we have our metric unit on volume, and let's go ahead and take a look at a couple of English to metric units. Which is larger, a liter or a gallon? Well, a gallon is larger, holds just a little bit shy of 4 liters. A liter is slightly larger than the English quart. And let's look at millimeter and a fluid ounce. A fluid ounce is bigger than a milliliter. So 1 fluid ounce is approximately 29.5 milliliters. When you start talking about volume, it's the amount of space an object takes up. And in the metric system, the basic unit is the liter. Sometimes you'll see this represented by a capital L or a lowercase l. And the standard 1 liter is equal to 1 cubic decimeter. And that would be a 3-dimensional object, 10 centimeters by 10 centimeters by 10 centimeters. The big units we're going to use, excuse me, are going to be the liter, which is 1,000 milliliters. And if you're at all, bottles of pop, they talk about milliliters, like 590 milliliters in a bottle of pop, or 1 liter bottles. But when you start talking liter, it's 1,000 milliliters. 1 milliliter, or ml, can also be referred to as 1 cubic centimeter, or cc. And you hear about cc's quite often in the medical field. 10 cc's of epinephrine, or whatever it happens to be. But those are all equivalents. So 1 milliliter equals 1 cubic centimeter, or sometimes you'll refer to it as 1 cc. An interesting thing on water, 1 cc or 1 milliliter of water will also have a mass of 1 gram. Let's look at a couple of these examples below here. Which is larger, 1 liter or 1,500 milliliters? Well, 1 liter is 1,000 milliliters, so we would expect it to be 1,500 milliliters, and sure enough. 200 milliliters or 1.2 liters. 1.2 liters would be 1,200 milliliters, so that should be larger. And then 12 cubic centimeters or 1.2 milliliters. And when we do this one, it is going to be 12 cubic centimeters, because those are equivalents. You could say 12 milliliters instead of cubic centimeters on here. So there's some examples there. When you measure volume quite often, especially liquid, you use what's called a graduated cylinder. And you find this, the volume of liquids and other objects. When you have a graduated cylinder, you base your measurement on the bottom of the meniscus or the curve. And if you look at the picture on the left here, you'll see that you have this curve. So when you use a graduated cylinder, you look for the bottom of that curve. So in this example, what is the volume of water in the cylinder? It's actually 43 milliliters. You can see the top of the curve is almost at the 44, but you read from the bottom. The meniscus is caused when the molecules of water or the liquid are attracted to the sides of the container. And that's why you have this meniscus or this curve in a graduated cylinder. And you'll see this in test tubes and other cylinder type objects. Let's look at what's the volume of water in each of these cylinders. For cylinder A, which is they're all three are graduated cylinders, we would have 52 milliliters of water. Cylinder B would be 37 milliliters, and cylinder C, we're looking at approximately 23. Notice on here this is 20 to 25, so this would be 22.5, and it's a little bit above that, so about 23 milliliters there. When you have a solid and it's a regularly shaped object, you're very familiar with the length times the width times the height. So in this example, we have something 10 centimeters by 8 centimeters by 9. And if you do the math here, if my math is correct, it comes out to 720 cubic centimeters. An interesting way to find a volume of something that's irregularly shaped object, like a rock or a stone, you can use water displacement. If you've ever taken a bath and as you sit into the tub, the water level in the tub rises. That is the displacement. And you can actually measure the volume of an irregularly shaped object in a graduated cylinder. So if we look at our example here, the amount of water with the object, which is the one on the right, and that's approximately 260 milliliters. The amount of water without the object is 200, and so the difference between the two is 60 milliliters, so that would be the volume. Typically when you do these, use it for an irregularly shaped object, find a convenient line on the graduated cylinder, 100 mils, 200 mils, put the object in, slide it gently down the tube because you don't want any of the water to come out of the top, measure that, and then take the difference of the two. And that's the end of this one, another TRS production.